All right, so for this video, I'm going to focus on numbers 11 and 12 here. These are kind of like the level 2 kind of problems because notice how there's actually 3 different pieces within the logarithm. And the number 11 actually brings in cube roots, which we haven't talked about yet. But number 9 and 10, I'll just quickly glance over those. So when I have a logarithm that has a division, or again a fraction inside of it, you can actually separate these and expand them into 2 separate logarithms. So I can make log u to the 4th minus log v, and then we need to move 4th power in front, so it'd be 4 log u minus log v. All right, again, number 10, very similar, and I'm going to spend more time here on number 11. All right, so here's the thing with cube roots. So we talked about square roots in another video. So like if I had 64 to the 1/2 power, a 1/2 power really means a square root. So because we've talked about rational exponents before, the number on top is the power, the number on the bottom is the root. Okay, so I could rewrite this to be this, the second root of 64 all to the first power. Okay, now do we really have to write something to the first power? No, we do not. So we're going to get rid of that first power there. And then the 2 on the outside. So if there's a 2 on the outside of a radical, that means square root. But we don't have to write that 2 because, again, square roots only exist if it's at least square. Now, we would need to keep it if it was like a cube root or a 4th root, 5th root. But if it's simply just a square root, the 2 doesn't even need to be there. So it would be the square root of 64. So in this case, notice how on number 11, it's the cubed root of x times y times z. Again, this should be all to the first power. I can actually rewrite this logarithm to look like this. So I can do log of x times y times z all to the 1/3 power, right? Because if it's cubed root, 1 is the power, 3 is the root. So I can rewrite it to the 1/3 power. And now that it's an exponent, I can move that entire exponent to the front of the logarithm. So it would be 1/3 log x times y times z. And then I can expand this logarithm into 3 separate pieces. So I would have 1/3 log x plus 1/3 log y plus 1/3 log z. Okay, so the reason I was able to do that is at the very beginning, rather than keeping it inside of a radical or a cube root, I can change it into a rational exponent or change it to the 1/3 power, move it to the front of the logarithm, and then split it into its 3 separate pieces. All right, and now number 12, you might say, oh, it's pretty similar, except notice how the exponent only applies to z, right? X and y don't have it, only z does. So first let's expand this into its separate pieces. So it would be log x, because of multiplication we add log y plus log z squared. And then we got to move the square to the front of just that logarithm because it only affects z. So final answer is log x plus log y equals 2 log z. Well, not equals, I'm sorry. It's just plus. There we go, 2 log z. So that is how we expand logarithms with 3 pieces. Number 11 was the main crux of what I wanted to get to. Make sure to deal with exponents because logarithms and exponents go together and they're inverses of each other. So that is how we do those more difficult problems.